This is section 2.7 on combining functions. Okay, so on page 252, and take a look, we have to go up to problem 61. It's on page 252. Bottom starting with 7. That's up to about 15. Don't think we had to do those there. Positions. F circle G, G circle F, F of G, G of F, stuff like that. I think you can see that even though I'm raising it up at the bottom. And there we go. Okay. And number 9, f of x is x squared plus x. G of x is x squared. F plus g, you just add them up. 2x squared plus x, the domain is all real numbers. F minus g, I subtract, I just get x, domain is all real numbers. Fg, multiply them, x to the 4th plus x cubed, domain is all real numbers. F divided by g, however, x squared plus x over x squared, or 1 plus 1 over x, the domain is all real numbers except for 0 because we cannot divide by 0. 13, f of x is radical 25 minus x squared. G of x is radical x plus 3. F plus g is this function. As for the domain, let's see. Whatever is underneath the square root has to be greater than or equal to 0. Let's get this out of the way. X plus 3 greater than or equal to 0 means x is greater than or equal to 3. This one, 25 minus x squared is greater than or equal to 0. Add x squared. That means x squared is less than or equal to 25, which means x is between -5 and 5. So this has to be true, and this has to be true. So that includes only numbers between -3 and 5 inclusive. F minus g is just that, same domain. F times g, pretty much same domain. F divided by g, the only other thing for f divided by g is -3 is no longer allowed because you'll be dividing by 0. So the domain is parenthesis 3, 5 bracket. 17, give the domain square root of x plus square root of 3 minus x. So x has to be greater than or equal to 0, and 3 minus x is greater than or equal to 0. If I add x to both sides, 3 is greater than or equal to x, or that means x is less than or equal to 3. Both of these have to be true, so that would be bracket 0, 3. In order to do 21, you have to see the graph. So 21, use graphical addition. So I just plotted some points. Okay, unfortunately, I can't show you both at the same time, but you can just read off the graph together with what I have. For the F graph, I have 0, 1, 1.5, 2, 0, all the way down to 6, -2. You can confirm that on your own. G, I had 0, 2, 1, 3.6, 2, 4, 3, 4.2, all the way down. And so if it asks for F plus G, I just add them up. 1 plus 2 is 3, 0.5 plus 3.6 is 4.1, 0 plus 4 is 4, all the way down to -2 plus 2 is 0. And if you graph it, it looks something like that. 29, f of x is 2x minus 3, g of x is 4 minus x squared. F circle g, f looks like fog. This means f of g of -2. So first I figure out g of -2. -2 goes there. That's going to be 4 minus 4, which is 0. So this thing behind my pen is 0. And then I do f of 0, which is -3. Golf, g circle f, means g of f of -2. -2 goes there. 2 times -2 is -4. Minus 3 is -7. And now g of -7, put -7 there. 4 minus 49 is -45. And you will notice that f circle g is not the same as g circle f in general. They're two different values. Okay, 31a, fog, f circle g of x, f of g of x. G of x is 4 minus x squared, so it's f of 4 minus x squared. And f is 2 times whatever minus 3. So 2 times 4 minus x squared minus 3, 8 minus 2x squared minus 3, or 5 minus 2x squared. Golf, g circle f, g of f of x is 2x minus 3. And now that goes in for the function g. G goes 4 minus whatever you feed it squared. So it's 4 minus the square of this, 4x squared minus 12x plus 9. Clean it up, negative 4x squared plus 12x plus 4 minus 9 is a minus 5. 35, in order to get that, you have to see the text. 35. It's a G circle f of 4. So that's G of f of 4, which is G of 2. So f of 4 is 2. So that's 2. And then I do G of 2, which is 5. So G of 2 is up here. That comes out to be 5. And 43, f circle G of 6. See the text, so f of G of 6. G of 6 is 4. And then I do f of 4, which is 1. F of 4 is 1. Okay, 45, f circle f of 5. It's f of 5. F of 5 is 6. And then I want f of 6 after that, which evidently is 3. F of 6 is 3. Okay, 49, f of x is x squared, g of x is x plus 1. F circle G is f of g of x, that's f of x plus 1. And then whatever's behind my pen gets squared, so it's x plus 1 squared. Domain is all real numbers. G circle f, g of f of x is x squared. And now the thing behind my pen goes right there in place of x, so it's x squared plus 1. Domain is all real numbers. F circle f is f of x squared. And I take x squared and put it right there, so it's x squared squared, x to the 4th. Domain all real numbers. G circle G, G of x. G of x is x plus 1. Feed that thing into the function g right there. So it's x plus 1, which is x plus 2. So the domain is all real numbers. 55, here's f, here's g. F circle g, f of g of x is f of 2x minus 1. 2x minus 1 goes there. 2x minus 1 goes there. 2x minus 1 divided by 2x. Domain is all real numbers except for 0. You cannot divide by 0. G circle f is g of f of x, g of x over x plus 1. So right away, negative 1 is not allowed. And this mess behind my pen goes right there. So 2 parentheses x over x plus 1 minus 1. 2x over x plus 1 minus 1. The domain is all real numbers except for negative 1. F circle f is f of x. It's f of x over x plus 1. And now the mess behind my pen goes right there and right there. So it's mess over mess plus 1. So automatically x cannot be negative 1. Clean it up by multiplying top and bottom by x plus 1. This cancels out, so you have x. This cancels out, you have x. 1 times x plus 1 is x plus 1, 2x plus 1. So the domain is all real numbers minus a set consisting of negative 1 and negative a half. Negative half will give me 0 right there. G circle G means g of x, g of 2x minus 1. So right here, the next step, you put 2x minus 1. So it's 2 times 2x minus 1 minus 1. That's 4x minus 2 minus 1, 4x minus 3. Domain is all real numbers. 59, you have a composition of 3 functions, f circle G circle H. So f of g of h of x is x minus 1. So x minus 1 goes there. Then I want g of x minus 1. G takes the square root of that thing. So f of radical x minus 1. And f just subtracts 1 from whatever you give it. So radical x minus 1 minus 1. Okay. All right, so that was section 2.7.